everyone, my name is FATIN DALILA binti MAHADHIR from SSCP3333, and today I'll be presenting a simple physics simulation using Python focused on simple harmonic motion or SHM. So, what is SHM? In physics, simple harmonic motion is governed by Hooke's law, where the restoring force is proportional to the displacement from equilibrium. The object moves in a cosine or sine wave pattern depending on the initial conditions. Mathematically, the displacement is given by xt equals to x naught cos omega t. Now, let's go through the Python code. The goal is to simulate and visualize this oscillation by plotting displacement versus time. First, we ask the user to input three values: the mass of the object, the spring constant, and also the initial displacement. These are essentials because we want to calculate how the object will move over time. After getting the input, we will calculate the angular frequency using the formula omega equals to sec k over m. Then, we generate a time array from 0 to 10 seconds using numpy and calculate the displacement at each time point using the cosine formula I mentioned earlier. So finally, we will use matplotlib to plot the displacement versus time. This will give us a clear picture of the oscillation. To run this simulation, I will enter the value of mass in kg, spring constant k, and also the initial displacement in meter. Then, the graph of displacement versus time will show up on the screen. When you run this simulation, you will see a smooth wave going up and down, repeating periodically. This wave shows how the mass moves. First, it starts at its initial position. Second, moves to the other extreme and then comes back and will keep repeating just like a spring moving back and forth. To conclude, we understand that this is the motion of a mass attached to a spring moving back and forth smoothly. We also know that this is a simple code that let us explore SHM visually and also interactively. It is a great example of how computational physics helps us understand physical phenomena through the simulation. That is all from me. Thank you so much for watching.